Hey, and welcome to our latest dockware tutorial. This time we're trying to figure out how to create those new Shopware apps and how to use them in a smooth and easy local development environment using Dockware or Docker containers in general. And to make life easier for you, we've prepared a new sample. So in our example repository on GitHub, just download it, clone it. You will find a new apps folder with our sample demonstration and example from today's video. We tried to make it really easy, so there is a README file included that will tell you everything that I'm going to say anyway now. So we are going to create an independent product reviews application. So that means we do have a Shopware app without any really code. It just uses a webhook to transfer orders as soon as they are placed to our external system where they are stored and further processed. As soon as we do get a review in our external system, we just send it back to Shopware using Shopware API. So I think it's time to start up our containers and get going. You can easily start your containers using the Docker Compose app -d. So as soon as your images have been downloaded or directly started, your online shop and Shopware shop should already be available. So if we go to localhost/admin as well as localhost/mailcatcher, we should see the applications up and running. So the next thing is we log into the administration, go to the extensions, and just simply install and activate our app as we would do with a simple plugin. And don't forget to activate it. And that's the only thing you gotta do. Now we can simply open our storefront and place an order. So let's go to clothing, add something to a cart, and then we have to obviously register a new account in Shopware. And now we just place and submit our order. So that's it. But what happened? You basically see nothing, right? Our backend service sent us, as soon as he got the order placement, an email with a deep link to its own application in order to allow product feedbacks. So that is our product review application and not Shopware anymore. So it's reachable using localhost port 1000. It shows all the orders that are stored in that system. So we can simply open our order, select a product, and write a review for it. Once the new review is placed, you should see by opening your review in the Shopware store that our backend service automatically sent the new review directly to Shopware using the Shopware API. Let's check out the architecture. So when we've installed our Shopware app, there is a registration process of 3 steps being done. So the first is a registration request. There are some security handshakes things in there, but what will happen is that the new shop is being saved in a local database in our product review service container. So that is necessary to know what shops are using it. Afterwards, there is a registration response, and another confirm request where we get the actual Shopware API credentials, which are also stored in the database for further processing. When a customer in step 1 places a new order, step 2 is being fired, which is a webhook, an order placed event that will send the order data to our product reviews endpoint. So our product reviews endpoint backend service is saving the new order, at least the data it needs, in its local database. In step number 3, an email with a deep link is being sent out. Very important, we reuse the mail catcher for this example setup of the Shopware container. Usually, the product reviews endpoint would have his own mail server, his own mail catcher container, just to let you know, otherwise it might be confusing. So in step 4, if the customer is finally doing a review, step 5 is being triggered, which means that using the Shopware API, the new review is being sent to our Shopware shop. On to the source code. Let's see what this example includes. So we have our folder, and in that folder there's a Docker Compose for the setup, as well as a source folder with two sub-applications, the backend service and the Shopware app. If we open the Docker Compose, you should see that there are two containers involved. The first container under the name Shopware is actually the Shopware dev container, reachable with port 80. The other one, backend service, we just use a dockware flex and expose port 1000 for our browser front-end application. The source code itself, both app and backend service, is being done using a bind mount, so you don't need to do anything to get started or to modify an existing code. Now on to the fun part, the magic when it comes to local development and cross-communication between the two containers. So with plain Docker, host names in the internal network infrastructure are just the key names. So in that case, it's Shopware for the host name of the Shopware container, as well as server in line 17 for the name of the server backend container. That means Shopware can communicate with our backend service with the host address server. But the backend service container cannot communicate with Shopware because he doesn't know about Shopware. It's a dynamic registration process when installing the app. So the Shopware domain is localhost, but we gotta teach him that he must not send localhost to the backend service, because then the backend service would call himself. So we have to create any other domain that is callable in the end from the backend service. We do this by using the .env file in the Shopware container. The app URL is the one that is going to be used when an app registers a new shop with a backend service. When our backend service saves the new shop when it's being registered to its local database, it will receive from the shop the domain that we've just set. Now all we gotta do is teach our backend service that once he tries to call dockware app dev as domain, it should actually call the Shopware container. And that can be done with a links and an alias for that host. So that is all that we need in the Docker abstraction layer to have Shopware apps communicating with the backend service and vice versa. So now onto a Shopware app. So there's no code involved at all. Only the required manifest XML file is inside, so it has metadata, names, stuff like that, but also the setup stuff. So there's the secret, which is only used for development purpose, as well as the registration URL. So that points to our Docker container, the server host name for the registration process. In production, it would usually point to your real domain. Besides that, we have some permissions and the most important event, order placed event that we need as webhook, which also points to our development or Docker container hostname, which is again called server. Now let's navigate to the backend server source code. So first of all, there's no framework being used in there. That's all completely done from scratch, just to show you how it's done. And the code isn't that good, to be honest, but it's working. So we have a public folder, we have a source folder, as well as a separate logs and storage folder. The registration route can be found in public app setup. Registration PHP, it's just a PHP file, and let's see what it does. When a Shopware app is being installed, it calls the registration route on the backend service endpoint. And data is being sent obviously with that request. So we have a helper, a log request function, where you can easily get access to what Shopware sends to our backend service. For the registration, we have things like the shop ID, shop URL, timestamp, but also important header signature and other things that we need in the upcoming steps. The first thing we already need is to verify the signature that really our Shopware app calls us. So this is documented by Shopware, how to do it. It consists of the secret, the app name, but only proceed if the signature is correct in the end. Once this is all good, we know that it's a valid shop, so we create our shop, create a new secret for further communication with that shop and verification, and save it in our local database, which is just a JSON file in our storage folder. So you always have access and you can immediately see what is being saved in our dockware sample app. And as you can see, our new shop has already been registered using our dockware app dev domain. So that did already work by just setting the .env value. So the last step in the registration request is to create a proof. So Shopware does also verify our backend service if it is the real service. So that's documented by Shopware. But what we add in there is our domain, our file and confirmation route. In production will be a real domain. In here, it's just the host name of our Docker container. On to our file and confirmation step. What is being done in there? Shopware again sends us a request with data. So we can easily check out what is being sent. So we get a payload with the Shopware API credentials that we're allowed to use to access the shop data, and also a shop signature. So that one's based on our shop secret. We always also in upcoming requests have to verify that the real shop is calling us. So we grab the shop secret from our local database, rebuild the same signature, and make sure that the incoming signature is the same as that we know would be the result. If everything is okay, we can simply store the received API key and secret in our local database so we have access to the Shopware API of that particular shop later on. Let's see what will happen if a customer places an order and Shopware calls the webhook and notifies us. So again, we receive data, we can easily check out the log. So Shopware will send us a shop signature in the header, as well as a body with a huge payload. In that particular event, it's just the order, at least an array presentation of that order. So once again, we, as always, have to verify that it's the real shop or the Shopware app. If it is, all we have to do is we extract the order data and save whatever we really need in our database. So in the example, that's also a JSON file for every single order. As you can see, we have sales channel ID, order number, as well as some basic stuff about the line items. Last but not least, to have some kind of a nice feature in our example, we also send out an email, as mentioned and seen before, to our customer with a deep link where he can easily just navigate to our product reviews application to create a new product review. The place where the customer actually creates a product review is our own application and front end. This is not beautiful at all. So it's just a mixture of PHP and inline HTML. So don't judge me for that, but it's working. So there's a form built in which redirects to the send PHP, where again we extract and retrieve everything we need from our database, like the credentials, the API keys for that particular shop. And then we have an HTTP client that we use to post new review data to the Shopware API of that particular Shopware shop. After that, we just output some HTML deep links just for the customer. One thing I have to add if we look at the actual source code is there's a helper framework folder. So this is not important for you guys probably, because this is just for us because we didn't use any framework like Symfony. It's just request response stuff. The real source code isn't a lot at all. So we have some models, repositories, as well as 2 services. That's it. So even though there might be templates for Shopware apps or backend services out there, it's always a project-specific source code. Alright, that's it for our sample. So please keep in mind that it's always project specific what you are doing, but what we as dockware can offer you is how the links, the communication in both directions between your Shopware shop and the backend service could work in an easy and smooth way. Thank you for watching. Thanks for using dockware. See you next time.